Hello and welcome to this episode of Microchips. In this episode we will be building a YouTube subscriber counter out of an LCD module, an esp8266 which is a wemos D1 mini, and some other little components. So I bought these off Banggood a while ago, and basically they are a nice holder for the LCD module. Now you can keep them in clear perspex by just taking off the protector, but I like to spray them from the inside so it preserves the gloss finish of the perspex but allows you to colour it. Now what we need to do is measure and then cut away the parts we don't need. So first off, I've attached the LCD to the front plate, and we'll just roughly measure where the LCD hole lives. Once we've done that, we can then start measuring. So this is just a rough outline of where the LCD will sit. It's a little bit awkward to get the pen in on some positions. There, that should be good, just as a rough guide. And there we have a position of roughly where the LCD is going to sit. So now it comes to the point where we measure, and more measuring. So I've sped this up a little bit. Basically I'm just taking the dimensions, and I'm trying to get the dimensions of the actual display part of the LCD and leaving the rest. So once we get a center point, we can actually then measure the actual display area of the LCD. And you know the old saying, measure many times and cut once. Well, this applies to this. You'll see why, because that is a little bit adrift. So once we're happy with all the final measurements, what we'll do is we'll get a nice sharp scalpel and we'll cut the protective paper. Because what we're going to do is we're going to leave the center part on the actual perspex, but remove the outer part for painting. Because then once we've painted it, we'll remove the center part and there will be our window for the LCD to so you can see it. So just gently cutting away with the scalpel, and there we have so what we're going to use is some acrylic black paint, and we're going to use an airbrush to spray it. So here we are in my little spray area I have in my loft. Now I didn't find out till later that I'd actually made the paint a bit too thin, and it didn't come out exactly how I wanted it. But the idea is you paint the inside and then you can see the colour of the paint from the inside, whilst leaving the outer finish being the perspex. So I'm spraying all edges. And my airbrush keeps clogging up. I must have had some lumps in the paint. Trying to make sure all surfaces are covered that I want covering. So whilst that dries, we'll prepare the circuit board. So we're using good old-fashioned Vero board. First, score the Vero board with a knife, and then we should just be able to snap it. Always be careful with your fingers whilst doing this. Oh, you'll see why I've chosen this length of PCB in a moment. Just trying to make it as small as possible to actually sit behind the display. So then gently apply some pressure and it breaks. And there's our piece of Vero board already. So first we're going to insert a power terminal or PCB terminal. But first we need to make sure they don't short together. So using a Vero board cutting tool, which is basically just a drill bit, we'll prepare that area for soldering. There we have first connector. So you see why we need a hole in the middle, or else it would have shorted together. And it's easier to cut the track with it not being soldered. Now next thing will be a 5-volt regulator. Now the input for the regulator is on the right and the output for the regulator is on the left, and the center pin is negative. So you'll see that this just fits nicely on the circuit board. Now we don't really need a thermal insulation pad, but we'll put it on for heat transfer anyway, because these regulators do like to get nice and toasty, especially when dissipating from 12 volts. Cut away any excess thermal pad just to make it look nice. And there's our regulator installed on the heatsink. So, according to what we've just said, the input will be on the right. So if we join all three of these together, that will line up perfectly with the regulator. So we'll place the regulator in this position, and as you see, it lines up perfectly. So we'd have to do a couple more modifications to the tracks. Because negative will be centre. And you can see at the moment the negative line is connected to the output. So positive's correct. That one isn't connected, but this is the one we need to modify. And that's that isolated. Now if we make a solder bridge between these two, that's the regulator wired up correctly. Next thing, couple of capacitors, as per the data sheet. Luckily we can mount these nice and neatly with the centre leads going to the, should we say, the negative leads going to the centre. We'll solder these in. That's that tidied up nicely. Now, because of how the circuit is, we need to isolate that. That now isolates the input side of the regulator. Now, it just so happens that the wemos D1 Mini fits perfectly in the board as such, and the 5 volts and the negative are in exactly the right place. So 5 volt at the top and ground on the second one, which lines up perfectly with our regulator. So no other modification of those traces is required. Now, the next part is we need to isolate the sides, each side of the wemos. So we just run right down the centre. There, simple as that. Basically, that's our circuit built. We have input, we have a regulator, we have capacitors, and we have the ESP or wemos. Now, the LCD display we're using uses the I2C bus, so we'll need to connect some wires. So the first wire, obviously negative. It doesn't have to be first wire, but this is one we're putting in. So that's our negative wire installed. And now the positive and the 2 data leads. So these get soldered in once they're in place. Now these leads can be any of the connectors on the wemos, because I think most of them support the I2C anyway, but these are the 2 we're using that will correspond to the code that we will be loading into it. Just making sure the wires are flush with the board. And there we have it. That's our circuit built. So that's how it looks. So we'll colour code the negative input as black, just so there's no confusion when wiring it up. Okay, I think we're good for a test. So first things first, with no wemos plugged in, let's power it up, and as close to 5 volts. That's good enough. This is being fed off a 12 volt supply, so this is good. We'll power it up with the wemos in place. You can't really see the LED flashing on the wemos. Yeah, and it does. So the wemos is working. So now we need to make a couple of mounting holes. So we'll use our Verobore tool again, just to gouge out a little hole. We'll be using these standoffs, and what we'll do is we'll glue these standoffs to the base of the plastic LCD holder, just like that. But we won't glue it yet because it has to be glued in a certain way or else it won't fit together. Now let's do the connections on the LCD. Let's pre-tin them first. Always good for making a good connection. So starting with ground. As you've probably seen, all the parts for this are nice and cheap. All available off the likes of Banggood and eBay. And that's our data wires connected. And it will sit something like that. So let's do a quick power test. And we'll upload some code to it. Now the code, you'll have to change it to match the LCD display should the I2C address be different. I already know the I2C address for this because there are I2C scanners available that will tell you the device is connected. So we'll upload this to the wemos. And let's see what happens. And there we'd have it. Now, one tip, should you ever get one of these LCD displays and you get nothing on the screen, is make sure that the brightness control on the back is at least turned up, because they like to have a habit of sending you them with the brightness turned all the way down. So even though the code's working, you'll see nothing on the screen. Or should we say it's not brightness, it's contrast actually. But yeah. Now here's my painted acrylic. Unfortunately it didn't turn out exactly how I wanted it to, but a little bit of touch up with a brush will soon solve that. As you can see, it's not quite black. Must have got the mixture of the paint wrong. Maybe it was a bit too thin when I sprayed it. If we carefully prise off the centre masking, there's our window for our LCD. Now the paint's leaked in a little bit at the bottom, but we can easily just carefully just scratch that away. So remember, this is going on the inside. So if we just carefully peel away the front side of it. It's not too bad. I mean, if you wanted to leave this clear, then don't bother painting it. Or if you just want to paint the front and leave the sides clear, I just like to paint them. Yeah, I think I'll have to redo that one day. So we'll carefully fit the LCD. Don't over tighten them or else you'll end up breaking the plastic. So there it is assembled. I've done some touch-ups on the sides as well. And I've also glued the PCB to the bottom. So next thing, we upload the subscriber counter code. And there it is. Just after a few seconds, on it comes. So the plus 32 is for when you get a new subscriber. The 32 is the amount of subscribers I have at the moment. So if somebody did subscribe, it will come up plus 1, and the 32 would obviously increment to 33. It's a nice YouTube logo that somebody kindly made. And there we have it, a DIY subscriber counter. Now, like I say, the front paint didn't turn out exactly how I wanted it, but if you're not stood right up to it, it's not too bad. Anyway, hope you enjoyed the video. Thanks for watching, and we'll see you again.